Warm welcome from my side. Today's topic is all about real-time analytics and getting streaming data into an actionable dashboard. So my name is Gregor Bauer. So I'm VP Custom Engineering at CrateDB. Here is also my QR code. If you'd like to book a meeting with me, you can do that. You can also connect on LinkedIn with me. I'm glad to connect. So first of all, we're going to start a bit about what is CrateDB. I guess not everyone has heard about it before. So who are we? So we're an open source database. I've been in the industry for 12, 13 years. We're an Austrian founded German company, and we have 17 million downloads on GitHub, also 6,000 stars. We have hundreds of nodes and multi-node clusters worldwide. The team which built it comes from all kind of different database backgrounds. So that is basically why also we put the best of all of the different database worlds into one together, and also trusted by our valued customers worldwide. So what is CrateDB? It's basically a mixture of different stacks. So per definition, we're a relational database. From outside, we look completely relational, but under the hood, we are also NoSQL database. And because of our query engine, which is on top of Apache Lucene, we also have other capabilities. For example, a full text search, also vector search, which comes with that ecosystem. We're very good at TOC queries, so everything sub-millisecond without indexing. A lot of ingests, that's where we're strong at, but we come to that in a second. So a few of our live examples of our customers. So whenever it comes to stream processing, IoT data, real-time analytics, that's where we're strong. A few examples, what we have here. One which I always like to reference is Rauch. Not sure if everyone knew, but Red Bull, the filler for Red Bull, that's Rauch. So in the end, Red Bull is only a product company. They don't fill anything themselves. And if you come to actually drink one of the cans, flip it upside down, there is actually a batch number underneath. And this ID you can find in CrateDB in our database, where we have the use case with them. With them, it's all about quality assurance. So they want to measure the cans, how they're produced, under which circumstances, to reduce the waste, because they want to have everything exactly tasting the same worldwide. Other use cases, for example, Bitmovin, also a cool use case. Everyone who has Netflix uses that system in the back end, and it's basically optimizing in real time the encoders for your video streams. So depending on your network traffic, on package drops, there's little settings they can do in the back end to make your viewing experience better. Again, real time, making quality better for you, that's what we're good at. So let's talk a little bit about our core of the database. So what can we store? Because we are using Apache Lucene, we have a combination of different data models. For example, we store tables as such, but without any schema. So that's the cool thing about it, complete flexibility in the data model. You can basically store whatever you like, every line can look different, no fixed schema, and that allows us to store tables, relational data, JSON, time series, and geospatial, full text search, and blobs in a single row. That allows us also to have then dynamic schema, real-time user-defined functions, so functions built on top of your data, which you can easily query. We also have CDC, so change data capture, meaning we can from our database also query other databases to combine the results for searches. The storage engine is completely distributed. So that means we don't have single node systems. It's a distributed multi-node system. And also the query engine is distributed. So that means no indexing necessary. We can ad hoc query because we parallelize everything. And exactly the same for ingest. So high ingest and reading immediately. From storage perspective, it's columnar, so you can guess it's already very good with ad hoc aggregations, so everything around min, max, average, rolling averages, that's what we can do. And of course, we bring high availability and also horizontal scalability because of the distributed system what we have. Where do we deploy? Nowadays, very important that we also have edge deployments, so very good for IoT use cases for measuring, but also hybrid. So that means you can have it on-premise, in your own data center, in other data centers, and of course, fully managed also in the 3 big clouds. They can all talk to each other, so synchronization is possible, and the source or the software is the same everywhere. In nowadays, with data sovereignty, that's key. So that's everywhere can be deployed. Native SQL, that's what we built on top. So every Postgres connector you have will work with us because we implemented the Postgres wire protocol. So that's quite cool. So we hook on that ecosystem, and as you can guess, it's huge. So that brings us the possibility to get all kinds of data into the system. May it be from enterprise data, CRMs, ERPs, IoT devices, sensors, telemetry data, but also unstructured data, also for AI and so on. So that's all what we can ingest. Here you see some of the examples of the connectors. So it could be via ETL process, also batch processes working easily. Streaming data, that's what we usually prefer because that's how you can actually get real-time insights of data if you also get them in real time. And what can we do with it? Then this is a few of the examples of what we do. End-user applications, of course, but very often it's dashboards, it's analytics and BI tools, recommendation engines, also fraud detection, predictive maintenance. This is all what you do when it comes to real time. Good. So that gives you hindsight, analyze historical information. Inside, we can also have current events analyzed to get insights, and also foresight to predict with the information what we get, how it will behave in the future. As I said, deployment-wise, cloud, database as a service, and the 3 hyperscalers, and also a new GDPR-compliant German clouds are coming up next. Private clouds, on-premise edge, also Kubernetes and OpenShift. So what do we actually solve? Limits on scalability. And how do we do that? If you compare traditional databases, the problem always is that it's usually monolithic systems. So big box, and if you scale, you need a bigger box. So that doesn't scale. So we scale horizontally, and that means limitless. So you can scale from 3 nodes to 1,000 nodes, which large customers of ours have actually. Insights not available in real time. Biggest problem in the market, I would say, from ingest to query, the latency is actually the problem here. So other systems, you need to have ETL jobs maybe and have something to translate it or transform it. That takes time. If you need to have the information in real time, you need a different solution for this. And Crate is one solution where you can ad hoc query everything in milliseconds because of the distributed query engine. Rising data volumes, if I see what the prices are for storage nowadays, especially in the clouds, then it's good if you can also store it on hot, warm, and cold data to just save costs. Because some of the customers I've seen, they spend thousands of dollars monthly just for storage, which is insane. Then also decentralized siloed data. I think every one of you knows that different departments have their data in different systems and different databases. If you need the data to query all at once, that's a big issue because it's coming out of different systems. With Crate, actually because of the connectors as well, we can grab the data and have it centralized in one system to get real-time insights into your processes, your manufacturing, and so on. Also, augmented, increased productivity. We have AI support, so vectors can be stored locally in the database. You don't need anything else. Also, MCP and agents can also talk with us. Then operational costs, because we have a super distributed system, that means also we can lower our costs for CPU, because you don't need big boxes, which are potentially more expensive than more but smaller nodes. All right, so I'm going to show you next what actually is meant with real-time analytics and dashboards. So the challenge we have nowadays with a time series is, well, first of all, they're everywhere. So everything you do daily produces time series data which are stored in whatever systems. If you surf somewhere, if you shop somewhere, if you walk around, even on your phone, that all is time series data. And it's a quite vast majority. The problem is keeping up with that data because it's getting more and more, and querying that to get some meaningful insights out of it. That's challenges what everyone has. So the example architecture is quite simple, but this is how you would typically do. You have some producer of any kind, could be sensor data. In this scenario here, it's sensor data which we load over a VM, and then we stream it over Kafka into the Lambda storage, so the Lambda function in AWS. So that's serverless, quite lightweight, quite cost efficient, which then batch loads it into Crate. So extreme load of sensor data into Crate, and then we have a dashboard running, which then allows us to get insights of what we see from a sensor perspective. How does the data look like? It's temperature data from a European project. It's called Copernicus, which measures data worldwide. So analysts and researchers can use it. The structure looks like this. So it's a timestamp, lat, long, and temperature. Very simple, but it's available, large data sets from everywhere in the world with timestamps. So how does it look from a CrateDB perspective? And the ones who write regular SQL already can see how easy it is to combine different data models into a single query. Because what you see here is relational, it's geospatial and JSON data in a single query. And you can adapt it on the fly. So the next insert, if you change something, no schema change necessary, just go on and insert the data. Full flexibility for your use case. So the user interface which we created is basically Grafana, and this is what you can see here. It's basically in real time displaying it visually what the sensor data, the temperature data sends us. So, for example, you can see heat waves coming in. You can see the different temperatures from North Sea and close to the Alps, how it differentiates. And also, what we're very good at is not only querying the data to display them. What we're also good at is aggregating them ad hoc in real time. For example, if you have measurements from these kind of systems, to get the actual minimum, maximum, or average for the last measurements what you got. So you can really see in real time how your production process, your sensor data is changing. You can create alarms out of it and so on. So let's run the demo. So hopefully that works. So that should be now a video. Yes. So here I'm loading basically the producer. Hopefully you can see it. What's happening is basically it grabs these large files which contain all the temperature data. Then it batch loads it sequentially, all the data, and then streams it over Kafka. Then from the picture, what I showed you, the diagram, it's using a Lambda function to react to all of the stream data. So it only spawns the function when it basically gets it, and then stores it as batch in Crate. So batches are usually better than just single inserts, but that's for most of the databases. We can basically combine hundreds of data and then write them at once. So that gives us a huge advantage of speed. So what you can see here is then, and I think maybe you can see it, I click on the refresh button so to get to visualize it faster. In the background, there's massive ingest processes, and here you see the heat waves coming in, the temperature changing. So just imagine this being a manufacturing process in your plant, where you have heat information of processes which are not ideal, and with this technology, you can really look in real time at the data, what they're produced. And if you look at the lower section here, this is basically the aggregations I talked about. So, for example, it's the temperature readings, min, max, average, and you saw the lines are actually changing and calculating in real time. So that's amazing because you can really see how the trends are from previous readings to actual readings. Is it the same? Could be vibration levels on the manufacturing process, but could also be pressure or whatever. That you can aggregate it in real time is a quite complex problem because it's not pre-calculated, it's getting calculated on the fly, right? So when you look at it, it's getting created. And the queries behind are quite simple. Min of the time frame you selected, average, max, and so on. We can also do it with pressure, that's the middle one. And on the right one, there is even calculations being done on the fly. For example, wind speeds. The wind is basically measured in x, y coordinates, and if you want to have then the actual direction and the speed, you need to have a square root calculation. And this is also done within the database and being visualized in real time. So no need to ETL something, you basically do everything on the fly whenever you get your data. So if you want to learn more about Crate, you can do so. We have an academy. You can access it at learn.cratedb.com, where there is 2 courses where you can get a certification from. Also, easiest way to try also is going to the console.cratedb.cloud. So it's the cloud offering, which you can select then in the 3 big major clouds. It's free forever, so you can try and do your project on it. If you like, we also have later in the afternoon a hands-on session where we try or we recreate what I showed you here. And then you can try out this query also in real time. If you're interested, also, we have a booth here. It's C65. I'm happy for everyone. If you have questions, and just drop by. If you have follow-up questions, come by and stop by. Is there any questions?